I'm glad you remembered. So let me tell you a little bit more about the rates of college cheating. In 2020, the the International Center for Academic Integrity conducted a study which showed that the percent of undergraduates who admit to cheating in any way in college is 32. 25% of students admitted to using unauthorized resources for an assignment. 28% said they worked together when the instructor specifically asked for individual work. And 15% said they paraphrased or copied more than one sentence from a source without citing it. So I've been really interested way back when in studying more about college cheating. And in 2001, I started working on a project to study perceptions and attitudes about cheating among engineering students, which we affectionately call the PACES project. In our project, we created a survey that we administered to over 600 engineering undergraduate students at 11 institutions. All class levels were represented by this sample, including pre-engineering students at community colleges. We had a variety of different institution types from across the globe. So besides asking students about their actual cheating behavior, we asked about factors that might influence whether they decided to cheat. And we found some interesting things. We found that how a student describes a behavior influences whether they'll cheat. So by that, I mean, if a student had a more relaxed definition of cheating, then obviously they'd be more likely to engage in that behavior. We also found that prior cheating in high school, being a senior student versus a first-year student, and being on scholarship all predicted exam cheating. On the other hand, we found that moral obligation not to cheat was a pretty universal deterrent to cheating, and students often said they cheated to alleviate stressful situations. We also found that students rationalized their cheating behavior using instructor-based neutralizations, like things like the instructor was unfair, or the exam was too long, or they didn't cover the material. So there were a lot of insightful things that we found. This student comment sort of further illustrates that point. The student says that really the only way to put yourself on an even playing field is to cheat. So as we thought through these issues, we realized that we were sort of asking the wrong question. What we really wanted to know was more about students' ethical development. We wanted to know what caused them to become more ethical individuals. So at that point, our team engaged in the SEED project. So through interviews and focus groups, we created a survey of engineering ethical development, the SEED survey, which we administered to over 4,000 students at 20 sites across the country. The SEED survey included an inventory of places that undergraduate engineers might receive ethics instruction. And this table describes the most common pedagogies and settings in which that ethics instruction occurred. So you can see that the most common pedagogy in which ethics instruction was delivered was presentation by a professor or somebody else, followed by having discussions in the classroom with classmates. The most common setting included introductory and advanced level engineering classes in college, followed by non-engineering courses and other non-engineering but in college experiences. One thing that we found in our data was that the quality of the ethics instruction that the students received was more important than the quantity of it. So this student quote is an example. This student said there was really no discussion of the bigger impact of ethics. So that was something missing from their career. Contrast that with this student comment who said, the professor really encouraged us to do independent thinking and formulate our own opinions. So there really is a dichotomy between the way ethics instruction is delivered in the classroom. We also found that this ethics instruction, though it's delivered in the classroom, isn't always internalized by students. as illustrated by this comment, where the student describes that the faculty don't really talk about engineers' influence on society and corporate responsibility. The thoughts of others on this topic were also interesting. As I mentioned, we not only did surveys, but we did focus groups and interviews with administrators and faculty. And in many cases, those comments provided further evidence of the need to move beyond ethics instruction. This faculty member, for instance, pointed out the question of how do we really prepare students to go out and operate in the corporate arena when they get out? So at this point, I really wanted to dig in more and learn. I was really, excited and keen to learn more about ethics instruction, but my career took a significant detour. I took a long break from doing research about ethics to establish the Center for Research on Learning and Teaching and do faculty development for many years. And then I also launched the Engineering Education Research Program at Michigan before returning to a tenure track faculty position in electrical engineering and computer science. So at that point, then I was able to reestablish some research in this space. And I connected with Professor Aaron Seck in sociology to engage in a project to study the impact of ethics instruction on engineers' professional welfare responsibilities, or their ability to serve as public watchdogs, if you will. So we call this the Watchdogs Project. Our project involved conducting a survey of 120 working engineers. We did this through a representative sample analysis with MTurks. And these engineers had, on average, almost 10 years since they had received their highest degree. So they'd been out in the workplace for about 10 years. We asked them about the types of ethics instruction they received in their undergraduate education. And we asked them about 3 specific types, and I'll explain that in a minute. And then we also asked them to tell us how they might respond to different ethical scenarios that we presented. So one of the categories of ethics instruction was recognizing ethical responsibilities. And 32% of the respondents in our sample said that they had received instruction in recognizing ethical responsibilities in their undergraduate education. 29% said they had received instruction in understanding the societal consequences of design. And 19% said they had received some sort of instruction as undergrads about being mindful of public responsibilities. So these numbers really are not as high as we had hoped. But this table presents in simplified form some of the relationships between whether or not engineers received training in those 3 types of ethics instruction and their response to these ethical scenarios. So first of all, let me point out that engineers who received training or instruction in all 3 kinds of ethics instruction were statistically significantly less likely to believe that the ethical scenario we presented was irrelevant to them in their work. So they were more likely to say the scenario was relevant. Those engineers who had received training also were statistically significantly less likely to say the scenario happens all the time in the organization. So they were more likely to recognize those scenarios as happening. They were less likely to say that reporting the situation was outside of their comfort zone, or more likely to be comfortable reporting an ethical situation. And they were also a little bit less likely to say their colleagues might respect them less if they reported it. So they would be more likely to say their colleagues would respect them more. So we are still in the process of analyzing some of this data, but we found some really interesting findings. We found that the ethics instruction that engineers receive as undergrads is positively related to the likelihood that they'll recognize ethical scenarios as being relevant to their work, the likelihood that they'll notice those ethical scenarios happening in their workplace, that they'll be comfortable reporting scenarios if they see them, and that they would believe that colleagues would respect them. But unfortunately, less than a third of the practicing engineers actually had that sort of instruction. So the main takeaway is that ethics instruction in undergraduate education does appear to have a lasting impact, but only if it happens in the first place. So Professor Sheck and I have continued to engage in our work, and we're now looking at a second phase of our Watchdogs project, which is looking at the long-term impact of ethics instruction that's delivered in 4 different contexts, not just undergraduate education. We've created a survey which we administered to over 500 working engineers using an Ipsos system, which is another way to get nationally representative data from a survey like this. On average, the age of our respondents was about 44 years. So these engineers have also been working in the profession for some time. So we asked these instructors to tell us about the ethics instruction they received in 4 different contexts: in their undergraduate engineering classes, in other parts of college, in the workplace, and in the professional societies like IEEE or ACM, the places that they might be trained as professionals. And we also asked them about their understanding of ethical responsibilities along those same 3 categories that I talked about previously. So as I mentioned, we're still in the preliminary stage of analyzing this data. We're trying to analyze it and write it up, but I do have some preliminary findings that I can share. We found that engineers who have had ethics instruction in engineering classes were more likely than those who didn't to understand their public welfare responsibilities, or more likely to be watchdogs along those 3 factors that I described for ethics instruction. We also found that engineers who had instruction in other parts of college and in the workplace were not very impacted. So those types of instruction didn't have a major impact on engineers' understanding of their public welfare responsibilities. We did find that ethics instruction that was delivered through the professional society did have impact, but it was comparatively uncommon in our sample. And sadly, we found that almost a third of these 500 engineers said that they had never received any ethics instruction at any point in their education or career. So we're still digging into some of these findings, but it does raise some important issues. So what I'd like to do is to propose a different approach to engineering education based on some of these previous findings. I think it's important to deliver technical content, of course, to engineers, as well as ethics instruction, but we need to go beyond ethics instruction and consider ways to also educate our students in social responsibility. We need to provide them with a sense of social responsibility, and we can do that in a couple of ways. We can do that by integrating issues related to public welfare responsibilities into their courses, and by integrating socio-technical concerns into their technical courses as well. This quote kind of provides further evidence for that approach by Dr. Kadir at UC Berkeley. He says that engineers have had a really key role in creating the physical and regulatory structures that lead to discriminatory outcomes. We don't often teach this in our engineering courses, and it's incumbent on us to prepare our students to be able to address real-world issues with this in mind. So I've been engaged in 2 different course-based approaches that might allow us to achieve the goal of integrating social responsibility and ethics instruction into courses. The first is a 2-session graduate module that I'm working with Aaron Seck on, about introducing engineers to their public welfare responsibilities, and this is for electrical engineering master's degree students. And the second is an undergraduate module that I'm working with Gracie on, as well as Susan Lord at the University of San Diego, to introduce engineering undergraduate students in the Introduction to Circuits course to socio-technical implications of EV batteries. So let me start by describing this graduate level course. It's a 2-course sequence integrated into this graduate level master's degree course, which allows the typical master's student in electrical engineering. These are typically students that have gone off to the workplace and have several years of experience that they can use, and they can apply that in this course. It allows them to really apply those experiences in a classroom setting. So before coming to class, students read an opinion piece that Aaron Seck and I wrote for the ASE Prism that talks about engineers' public welfare responsibilities and describes the important role that institutions of higher education can play in that, in instilling those. Students also complete a survey that describes a little bit more about the instruction they had prior to coming into that class about ethics. During the class session, the instructor introduces the IEEE Code of Ethics, and students discuss the prior instruction that they had about ethics before coming into the classroom. Between the 2 classes, students complete an assignment where they write about an incident that they have encountered in the workplace where they think more instruction in the professional responsibilities of engineers would have been useful. During class, the instructor starts by comparing the extent of ethics instruction that the students in the classroom have received and compares that to what the practicing engineers have received. And students actually then also talk about the places where previous instruction would have been more helpful. And the instructor also then talks about ways the engineers can intervene on behalf of the public when ethical scenarios arise. As a final assignment, the students go out and outline an issue that is of interest to them in the form of a public outreach statement. So let me explain a little bit more about what sorts of prior instruction the students talked about having in their courses. The students had some really interesting insight. One said that what was missing was this understanding that non-technical aspects of engineering are a fundamental part of the engineering core. Another student said that ethics wasn't really treated as an integral part of our undergraduate education. And a third said that most engineers understand the impact of their innovations, but they're often confused about what specific things they can do in ethical scenarios. So this table compares the ethics instruction that master's degree students in blue and practicing engineers in orange have received along these 3 categories: recognizing ethical responsibilities, understanding societal consequences, and being mindful of public responsibilities. Notice that most of the engineers in the class said they primarily have received instruction through their previous undergraduate education, whereas the practicing engineers say they've pretty consistently received instruction across all 3 contexts. The students' reflections about when instruction on the professional responsibilities of engineers would have been impactful or helpful are really quite interesting. They basically fall into 2 different categories. The first category is students said they wish they knew a little bit more about when they could speak up. As this student commented, when he said that because of external expectations placed on them by the company, there was a sense of urgency put on the new employees that basically resulted them in doing unethical work. So they didn't really know when it was okay to say something or how to, react in response to a negative situation. So that was an opportunity that we could potentially provide more training for. Students also identified the category of learning when and how to address difficult issues as things missing in their undergraduate instruction. So one student said the skills and awareness about ground level issues is needed. Another said they were missing the skills to differentiate between having different points of view and being disrespectful or intimidating. And a third student said they were missing the skills to identify bias in the workplace and to be able to treat all people equally. So these are some opportunities for us to think about educating our students differently in the workplace, in the classroom. The students raised a lot of interesting points in their op-eds that they did at the end of the class. They raised a variety of technical issues, from autonomous vehicles to military technology, and they talked about a variety of implications relating to health and safety risks and discrimination. They really were quite insightful. I will let you read through these quotes from different op-eds. So I think this assignment really challenged the students. It really gave them a chance to think outside of the box and come up with some ideas for how they might proceed in the future. It's like you're still reading. So this work is still in progress, and the next steps for our Watchdog project involve further piloting this module. We piloted it twice in 2 different EE master's level courses. We hope to pilot it again next fall, and we're also considering piloting it in a senior level electrical engineering course this semester to see how the results might compare. We're also in the midst of finalizing the analysis of our Watchdogs data from the surveys that I described before, and we are conducting longitudinal interviews of 60 master's degree students from their education into the workplace, and we're halfway through that. So both of those 2 research projects will inform future iterations of our module. And based on that, we hope to refine the module and offer a full semester course for EE master students in the future. So you'll have to stay tuned for that one. And then the second approach to instilling in students a sense of social responsibility involves an undergraduate course module that I'm working on. To really better equip instructors to be able to integrate these socio-technical issues into their courses. So rather than us going into the classroom and delivering the module, this will equip the instructors to have that material themselves. And this module is one that I'm working with Gracie on. In fact, she's actually designed the module. And we're also working with Susan Lord at the University of San Diego. So starting with the conflict minerals module that Susan launched in her circuits class at San Diego 5 years ago, we're using that framework to design a module here to help students explore the life cycle of EV batteries and use principles of the circular economy to address issues that might be present when we're thinking about EV batteries. This is really quite a timely and important issue. EV batteries are obviously on the rise. And by some estimates, spent EV batteries can have as much as 80% of their original energy or their rated energy available at their end of life. Recycling batteries is one possible way to use those, but it does introduce societal risks. For instance, the batteries might explode when they're being recycled. It's time intensive and expensive, and there are often toxic chemicals required to do the recycling. Repurposing the batteries for other uses is an alternative approach that might alleviate some of those societal risks. So because the goal of this project is to really give instructors the ability to bring these materials into their own classrooms, we've been intentional to apply the principles of backwards course design, so that the learning objectives for the module and the pre and in-class instructional activities and the assessments to really gauge students' understanding are all interrelated. So we've started by defining 3 learning objectives for the course that connect the technical circuits content of the course with the social responsibility outcomes that we hope to convey in students. When students successfully complete this module, we expect that they will be able to design a voltage divider for a DC voltage source that would allow them to illustrate repurposing second life EV battery packs. Second, we expect that they should be able to estimate the energy available in end-of-life batteries. And third, we expect that they should be able to describe different kinds of societal risks that are introduced by recycling EV batteries that could be alleviated if we think about applying circular economy principles and repurposing the batteries. So the pre-class and in-class activities follow from those learning objectives. Before coming to class, students listen to a podcast about the circular economy and they answer some related questions. And they also estimate the voltage capacity of current EV batteries in the year 2030. And they estimate the demand that could be met with those spent EV batteries. During class, students discuss those pre-class estimates, and the instructor describes to them the principles of the circular economy and relates that to circuits concepts of the voltage divider and Kirchhoff's current law. And then students talk about different ways that the circular economy could be used to repurpose batteries. During their homework, problems, and on the exam, the students complete assessments to really gauge their level of understanding with the material. They list different kinds of societal risks that might be introduced by recycling EV batteries. They describe how the principles of the circular economy could be applied to repurposing EV batteries. They go through calculations to use a loaded voltage divider model to calculate the voltage, resistance, and power of a second life EV battery pack. And then finally, they estimate the effect of degradation on EV battery repurposing. So Gracie has completed the development of the module, and the next steps are to pilot the module. We're hoping that she'll be able to do that this semester in Susan's class at the University of San Diego before launching it more broadly at Michigan and other places. Once we pilot the module, we'll develop a complete set of lesson plans, in-class talking points, and assessment materials for instructors so that we can just deliver a package of materials to the instructor and they can easily integrate the material into their own class without requiring a lot of outside information. We'll also come up with some rubrics and evaluation metrics to assess the impact of the module on students' socio-technical knowledge, as well as their sense of social responsibility. And if our pending NSF grant is funded, we'll create and test more socio-technical modules for the circuits class that address different kinds of social dilemmas so that instructors can have a variety of options to choose from. So let me wrap up by providing sort of a contrasting view of engineering. One that places engineers on a pedestal, who are like rocket scientists, who are skilled in the expertise of their technical discipline, versus one in which engineers are viewed more as socially engaged citizens. We owe it to our students to do more than just educate them technically. It's an imperative that we integrate ethics and social responsibility into the classroom. And we can do this by creating opportunities to help engineers learn about their public welfare responsibilities, and by also integrating socio-technical content into introductory and advanced level engineering courses. So on that note, I would just leave you with some references and invite you to ask some questions. Oh, the chat is disabled.
The chat is disabled, but there should be a lot of questions here.
Okay, yep. So I think you can ask questions by going to the Q&A. The way the Zoom is set up, it doesn't allow people to ask questions in the chat, but feel free to send your questions in the Q&A. Any questions?
Thanks, Cindy. This is really fascinating work that you're doing here. You mentioned early on rates of competing. We looked at any differences among types of students. For example, engineers versus people in LSA versus business school students, and what have you found?
Yeah, we did. We have sliced the data so many ways. We had so much information, but mostly we had engineers. We did find that some disciplines of engineering were more or less likely to report the tendency to be unethical. We also, in the project I didn't talk about here, studied engineers and humanities students at Michigan, and we found that engineers tend to report being more likely to engage in unethical behavior than humanities students. But as I say, we kind of slice this in lots of different ways, and I'm only just kind of scratching the surface. But one of the key things that we realized during that analysis was that you can find lots of different reasons students cheat or certain kind of students that cheat, but really student cheating, I think, is at the heart of the issue. I think the heart of the issue is finding ways to, across the board, educate more social, responsible, or ethical students. Yeah, Chris.
So one of the things, so in, at least through ASW, the chemical engineering division, we talked about ethics instruction quite a bit, and we always relate back to case studies. And case studies, at least in the chemical industry, it always seems like there's a right or wrong answer. And so how do you go about, like, you know, the students seem to know what the right answer is that they really want to hear versus them going out into the real world and doing the right thing.
So the question was relating to, if you use case studies in the classroom, it typically seems like there's a right and wrong answer, and students might give you the right answer rather than really be pushed to think more ethically. I think there are ways to bring case studies into the classroom that are more gray, and probably if you're in the chemical engineering division at ASWE, they're pulling from a lot of the repositories of case studies. But you're right. I mean, you can only present the bridge collapse and talk about the fact that the ethics of designing the, you know, the support mechanisms, that the engineer should have caught it or something. I mean, there's only so many ways you can spin that to make it not seem like there is a right answer. But I do think that there's kind of a push towards integrating these, like going away from case studies, keeping case studies, but maybe adding in other pieces that really introduce students to, like, some places it's called macro ethical responsibilities, or Gracie and I have been using socio-technical content into the circuits courses. But if we consistently introduce students to these ideas, rather than just delegate them to the first year class and the last year class, or in addition, bring these like social issues into the core of the engineering coursework, like the introduction to circuits course or the introduction to chemical engineering course. I think as we do that more and more, we'll build up students' sense of social responsibility, and hopefully down the line, we'll end up with a better place.
Thank you.
Hugo.
Thanks. Great presentation. Thank you. Considering the fact that we need more instruction in ethics in engineering, could you comment on the expected outcomes of, for instance, a mandatory course on ethics in engineering versus embedding ethics topics in other core courses like socio-technical, the ones you
Yeah, so he asked about the trade-off, I guess, between having a mandatory intro to ethics course that students take and integrating the content into courses throughout the student's career. We actually looked at this way back when in our seed study, where we had all those pedagogies and settings, and we looked at if the setting is an engineering class versus if the setting is a non-engineering class, like a required moral philosophy class or something like that. We did find that the ethics instruction not in engineering had less of an impact. That's the same thing that Aaron Steck and I are finding in our Watchdogs project, that if the instruction is delivered in the engineering courses, it has more long-term impact on the students than if it's in other parts of college. Those things do have an influence on engineers' ethical understanding and behavior, but not as much. So I think that that even provides more ammunition, if you will, for us to integrate all of this into our curriculum. But that being said, engineers don't feel comfortable doing it in many situations. They don't feel like they know enough about ethics. I mean, they don't want to teach Rest's theories of moral philosophy in their circuits course. But we think that this module, which can be a very easy, like it takes one course, one class session, and we are hoping to provide instructors with everything they need to bring the content into their course. So it shouldn't be that heavy of a lift. We think it'll overcome a lot of the barriers that instructors face in bringing ethics instruction into their classroom. Were there, comments in the chat?
Yep. Lisa Giuletti asks, she would love to hear more about pivoting away from or beyond adding to case studies and moving to macroethical responsibility as course concepts, and maybe like examples of what that looks like.
Well, the module that I just talked about is one example where, I mean, it's just, I think macro ethics and integrating socio-technical concerns really are two names for the same idea. I know Professor Johnson in aerospace engineering has also been looking at these ideas from a little bit different perspective. I think his work is more about coming into the classroom and helping the students learn more about ethics. So I think there are a lot of different ways to go outside of case studies, but really I think the key is for the engineering instructors to be empowered to integrate this material into their courses so that students see this is an important part of my education. It's not something that I go elsewhere to do. And my core engineering instruction thinks it's so important that it's part of that content.
Linda Anthony says, can you address the both and in contrast to either or challenge of covering both high-level socio-technical issues like EV batteries and also the in the trenches issues that practicing engineers face in the workplace, like submitting bogus timesheets of billable hours or bias in assigning teams, such as excluding non-native speakers of English from film projects?
Yeah, so that question was, there's a lot of different ethical scenarios. One kind of ethical scenario is just being mindful of how your work affects the public, but the other is more in the trenches, like not falsifying timesheets and identifying bias when it comes up in the workplace. And I think that, so the module that is on EV batteries, for instance, is probably not going to prepare students to know how to react if they are in a position to maybe falsify time reports, or how to raise concerns when bias is happening in the classroom. On the flip side, the module that I'm working on with Aaron to prepare engineers to be public watchdog professionals, I think will prepare students for those situations. So I think there's not a one size fits all. I think keeping in mind all of these different ethical scenarios that might happen and bringing different pieces in them throughout the curriculum is probably the best way that we can address those concerns.
There's one last question here. How difficult has it been to develop the module? Sorry, and Enrique Paulo asks, how difficult has it been to develop the modules? He's hoping we can develop several for other engineering disciplines.
Well, as I said, it's the basis of, well, Gracie's been working on it for a year, almost full time. I mean, she's been doing a lot of work on coming up with these modules. We really started with Susan's module on conflict minerals, which has been really well received at University of San Diego. And we've built a 3-year NSF proposal to prepare 4 more modules. So it isn't an easy task at all, especially if you're careful to really intentionally use the principles of backwards course design, come up with concrete, important learning objectives that connect the technical content of the course and the socio-technical or the social content so that students see them as really integral and the instructors see them as integral, not just a separate add-on piece. So Enrique, it is not an easy process, and it does take a while, but I think once the material is developed, it can be adapted for other cases. But maybe Gracie has something to add.
I was just gonna say, I think another thing too is that,
Can you speak up?
sorry, the material that we covered too, we're hoping to integrate other subdisciplines in ECE as well. So the material kind of lends itself to ethical issues that come up in different focus areas in ECE. And I picture that would be the same for other engineering disciplines as well. So while the development process may be iterative and hard, I think that the concepts are the things in the news today that are coming up. And so that was one thing that I thought was really exciting.
Any other questions, thoughts, feedback, suggestions? Yeah.
Sorry to keep popping up here.
Oh,
but
please.
This is just such great food for thought. When you mentioned, I think it's instructor-based neutralization, is that the term? Yeah. I mean, students say a lot of things, some of which are true, some of which are not. But when they say the exam is too long or you didn't cover it, maybe I didn't cover it, maybe I didn't, but maybe I didn't. To what extent have you explored this question? Whether these objections or whether these justifications students have to keep are in themselves hold some water.
Well, so we haven't really drilled down to see how valid those excuses are, but we have, back when, this was, I don't know, almost 20 years ago when we were doing that research, but we did come up with recommendations for instructors. I mean, just knowing that one reason that students cheat is that the instructor doesn't care. So as an instructor, that's even more reason to care about what your students are doing, because if they see you as a person, they'll be less likely to behave unethically. So maybe you do or don't write fair exams, but write exams that you think are fair. You know, don't try to stump students, and just being mindful of the fact that students are people and they're stressed about so many things. But there are ways that you can lower the stress in the classroom. You can help them connect to you. You can help them see you as somebody that cares about their well-being. So rather than figuring out how much truth there is in those rationalizations, they're true to the student, then, you know, maybe find a way to connect with the students.
Clay Walker asks, it seems like often ethics gets a single day or perhaps a single week in a course structure, often without any assessment activities associated. Can you talk about whether the ethics day or week is enough to be effective? And also, should we be working to assess ethics activities that we introduce? And if so, what kinds of assessments would you recommend?
So our earlier work showed that the quality is more important of the instruction versus the quantity. So those one-day ethics things, which are totally separate from the course, or the, you know, having the students go to a workshop about ethics, I think there's evidence that that is not as impactful as bringing it into the classroom. But it is also important to do some assessment of how effective or what kind of impact is the ethics instruction that you're bringing in really making. And that is the next step in the, well, I guess in both of those two modules that I talked about. In the graduate course module, we're collecting information from students about their ethical responsibilities, their knowledge of ethical responsibilities, their ability to respond to different scenarios. And in the socio-technical module in the circuits course, one of our next steps, which is also going to be part of the NSF project, is to develop some rubrics and assessment metrics to really determine the level of student understanding of ethics, the extent to which they have a sense of social responsibility, and connecting that with the circuits content in that course to really get at both the socio and the technical expertise that students are gaining. You had a question?
What are your thoughts on how cheating relates to, like, in some sense, the bigger problem of unethical behavior in industry, or designing something that's like hurting society versus sort of what students might think of as not the real world of the classroom? Like, is it?
Yeah, so his question is asking, is there a relationship, or do we know anything about students' propensity to cheat and engage in maybe other unethical workplace behaviors. We had a whole project on that where we surveyed. When I was at Kettering, the students were required to do a co-op experience. So we had the opportunity to work with people that were half-time in school, half-time in the workplace. And those weren't practicing engineers per se, but they acted a lot like practicing engineers. So we surveyed them and did some interviews and found that there's a lot of correlation between behaving unethically in college and behaving unethically in the workplace. And I think, so again, this comes down to instilling a sense of ethics and social responsibility in our students, rather than just trying to stop cheating. So yes, there is a relationship between college and the workplace and other, instances out in the world as well. And we can do a lot to help improve the way students behave in the college classroom. I see it's 11:25, and I think I was supposed to end 5 minutes ago. So I'll be happy to answer any questions you might have afterwards. I'll stick around. I also think that Fatima has ordered some snacks and drinks from Panera. We can't have them in this room, unfortunately, but feel free to grab those and mingle out there in the lounge. Thank you for doing that, Fatima. And thank you to Robin for organizing this today. And thank you all for coming in person and on Zoom.
And please sign in if you haven't and if you're here in person.